So in order to do what we're going to do in this video, you've got to be up to speed on the change of base formula. So the change of base formula, as it applies to logarithms, allows us to solve this equation. 2 to the power of x is equal to 10. If I want to know what exponent I could raise 2 to get 10, I can put this thing into logarithmic form. Log base 2 of 10 is equal to x. And then this is solvable by using the change of base formula, which says that if you have a logarithm with a base that you do not know how to deal with, or more specifically that your maybe calculator doesn't know how to deal with, which would be anything other than 10 or e, this is the same as log of 10 divided by log of 2, and you can make that any base that you want to make it. You can make it e, which would give you ln of 10 divided by ln of 2. You could punch that into your calculator. Or you could make it base 10, which again allows you to punch it into your calculator. In any event, this is going to be the key that unlocks the door for us to take the derivative of a logarithmic function. So we're going to look at this equation, y equals log base a of x. My goal is to find y prime. And then we can apply that to any base a that is a constant, like 2 or 7 or whatever. So to do this, obviously we don't know how to do this, but if we use our change of base formula before taking the derivative, I can rewrite this as log of x divided by log of a, and I can make this any base that I want to. And we're going to pick a specific base. We're going to pick e because we already know some stuff about log base e. We specifically know how to take the derivative of the natural log of e. I'm sorry, I said that wrong. The natural log of x we know how to take the derivative of. So if I can express my logarithm like this, ln of x divided by ln of a, we're going to be in great shape. Again, just to be clear, I'm making the point that this is the same as all of this. And this allows me to differentiate because I know the derivative of the natural log of x. So there's 2 ways to do this. We could do the quotient rule, but that would be a little bit more involved than it needs to be. We should take a note of the fact that ln of a, the natural log of a, is a constant. So I can just write this as 1 over the natural log of a, which is, again, a constant, times natural log of x, and differentiate this. All right, so because 1 over the natural log of a is a constant, I'm just going to pull that out front. 1 over the natural log of a. That's dealt with now. And then the derivative of the natural log of x is 1 over x. So my final answer is 1 over ln of a times x. Of course, if you want to put the x in front, so it's 1 over x natural log of a, that's fine as well. But this is the derivative of log base a of x. So let's look at a couple of examples here. The first one's pretty straightforward. If y is equal to log base 7 of x, the derivative would simply be 1 over the natural log of 7x. So as we've been doing, our pattern has kind of been to look at the simple example first and then and then apply the chain rule, make it a little bit more difficult. So let's do that with the logarithms as well. We're going to take the derivative of this function, which is the log base 4 of sine of x. So I've got an inside function. As soon as I see the inside function, I've got to be thinking about the chain rule. So let's apply what we know. We're going to take the derivative of the outside, evaluate it at the inside. So using my format, this is going to be 1 over the natural log of 4 evaluated at the inside. So this x, whatever this was whatever that is. So this sine of x will be on the denominator, multiplied by the derivative of what's inside, which is cosine of x. So this can be expressed as the cosine of x over the natural log of 4 times the sine of x. And you know what? I just thought of another point here that I'd like to make. If y is equal to 2x, we've talked about how the derivative is 2x times the natural log of 2. Take note of the fact that what's inside of the natural log here is the base. That's a common mistake that people make. People oftentimes take the natural log of the exponent, but it's the natural log of the base, whatever the base is. In the same way here, with this derivative of logs, we again are taking the natural log of the base. That's no coincidence that those are the same. We're taking the natural log of whatever that base value is. So again, in this case we have a 4, that's why we have the natural log of 4. Yeah, good. Point made.